Radioactive decay is when an excited nucleus loses energy in the form of radiation. Why would a nucleus be unstable, you may ask? If you think about the nucleus of an atom, you've got protons and neutrons. Those aren't just automatically going to be attracted to each other. There's some type of strong nuclear force that's making the protons be attracted to the nucleus. But sometimes those bonds that are created between the protons and the neutrons, there's going to be too much energy. That's going to start to make the molecules want to move around. So imagine you're playing a squid game where there's a pile of rocks and the goal is to make 4 of the rocks fall. Only 4. You recognize you're going to have to stomp a little bit around the rocks in order to make some of the rocks fall. But if you stomp too hard, too many of the rocks are going to fall. And if you don't stomp hard enough, not enough rocks are going to fall and you're going to have to keep stomping. So to figure out how hard you're going to have to stomp, you're going to have to do a little bit of trial and error. Similar process is happening with radioactive decay. It's going to emit a certain amount of energy. It's going to create some type of particle that is released. So when you're thinking about decay, you can think of it as different reactions based on different ages of people. Alpha decay, that's the first letter of the alphabet. That's the youngest child. When a child is throwing a tantrum, they're just gonna throw things. They're throwing whatever they can find and they're gonna throw it with both hands. So alpha decay is emitting 2 protons or a helium atom. In addition to those 2 protons, it's also going to emit 2 neutrons. So it is going to have an atomic mass of 4. So you can see on this equation, if you start with a uranium atom that has a molecular mass of 238 and an atomic number of 92. If it goes through alpha decay, that is going to lose a helium atom, otherwise known as an alpha particle, that has an atomic mass of 4 and an atomic number of 2. And it's also going to create another thorium atom where the atomic number is now 90 and the atomic mass is now 234. Beta decay gets a little bit complicated. Before people realized that there was more than 3 types of subatomic particles, they just talked about beta decay as beta negative decay. You may see references to beta decay. They're talking about beta negative decay. Beta negative decay is an outcome you don't necessarily want, where you initially were neutral, but now you see there's a positive and a negative option. You are going from a neutron, which is neutrally charged. That neutron splits into becoming a proton and an electron. It starts from a subatomic particle within the nucleus and splits into a positively charged particle and a negatively charged particle. The same thing is happening for beta positive decay, but because there are more than just protons, neutrons, and electrons, there are also antineutrinos, particles the size of a neutron that's negatively charged, and positrons, particles the size of an electron that's positively charged. When you have beta positive decay, what was initially positive, that proton, the other subatomic particle that is located in the nucleus, is now splitting into a positively charged positron and a negatively charged antineutrino. As you get older, you start to not really want to change yourself as much. You just want to let your light shine. The same is true of gamma radiation. When you have gamma radiation, you are only emitting a gamma ray or a photon. There's nothing changing about the element itself. All of the energy from the nucleus is just becoming a photon. One of the ways to show that light is both energy or wavelength and a particle. The energy from the nucleus is wavelengths, and it's exciting a particle that is released as a photon. When you have questions that refer to radioactive decay, they may give you a chemical equation to help you figure out what type of particle is being released, whether it's an alpha, a beta, or a gamma particle. They may give you parts about the atomic mass. They might tell you the proton number. They might tell you the atomic number. There's a lot of different parts that they might tell you. If you can understand how to interpret this chemical equation, this will help you a lot in figuring out, at least eliminating types of decay it could not be.